All right, so uh, I'm going to show you something. Let's start off by showing you something amazing. So if we go to ESASky, you're going to see a very familiar view of the universe. I'd say nowadays, I think most of us are familiar with this little ball of the universe. And we can zoom around, we can do all the standard things that you can do in this kind of view of the universe. And as we zoom in, we get higher resolutions and so on. Maybe over the internet, this will look a bit chunky, but of course, if you try it yourselves, it's going to be very, very smooth. And as we zoom in, we get higher and higher resolution. And I think if we zoom in here, many of you are going to recognize a little familiar shape here in the center, in this beautiful nebula. And this is actually one of the most famous images ever taken in astronomy. And we can actually look at it directly here in ESASky. So we can look at this pillars of creation image in full resolution and in context, and we can zoom in and get higher resolutions and so on. And of course, 10 years ago, they took another picture, since this original image is probably 30 years old by now. So they took another one by Hubble just 10 years ago. And as you can see, it's very, very stunning image. That's this one. But the most famous nowadays, I guess, is the James Webb image of these pillars of creation. And we can actually look at that one as well right here in ESASky. And here we go. So really shows off the capabilities of the James Webb Space Telescope. But this is not really the core use of ESASky. I mean, ESASky is more targeted at astronomers like yourself, so more science use case, not these outreach images that are very stunning to look at, but they're not super useful to astronomers like yourselves. So if we just enable science mode like that, we are directly going to see a few more scientific buttons show up. And basically what we do here is to provide you with information of what kind of data, astronomical data, is available in this part of the sky. So for example, we got almost 2,000 images in this part of the sky, 100,000 sources that are cataloged in this part of the sky. We've got almost 100 spectral observations taken in this part of the sky. And if we want to figure out what they actually use to create this beautiful image from James Webb, we can actually access that directly through ESASky. We just go to the images button here, and we'll see that there are all these different missions have data in this view of the universe. So if we move around, it's going to be different and so on. But in this case, we're interested in this particular James Webb image and try to figure out what they use to create this image. And we see that we got James Webb data in different wavelengths. We've got Hubble data, we've got Herschel data, and many, many more. So if we open some James Webb data, you can see directly here that we've got a lot of footprints. There are over 600 observations taken by James Webb in this part of the sky. It's a bit difficult to see here in yellow, so let me just change that to some blue or something. And here we go. We can also remove that outreach image since we are more interested in the science use case. So here we can see the actual scientific data, the metadata for each of the observations. And we can actually look at each of the images as well. Let's say we're interested in this one. We can click on it. We can look at the actual image preview of the image here, and we can more interestingly download the actual data, the science data, the FITS files, and so on directly from here. There we go. We start to download. Of course, this is going to be a huge file, so let me just abort it for now. But this is basically the core use case of ESASky. And you can also go to the archive itself. For example, here we go to the James Webb archive if you want some more information regarding this specific observation. So you can download more of them. If we want to download 3 of them, for example, we can do that. Anyway, this is basically the core use case of ESASky to allow you to access data. And this is a bit of a personal mission of mine as well, to be able to allow for easy access to the astronomical data for astronomers like yourself, so you can focus more on the, pushing the bounds of human knowledge of the universe. And that's also why I've been working on this tool since 2016, and also why I founded Winterway, which is basically specializing on tools like this that combine these powerful features with user-friendly interfaces, And it's also why we are involved with other projects like NASA ADS and the WAS Worldwide Telescope. But if we continue our little investigation here regarding this outreach image that was so beautiful from James Webb, we can probably guess that they use some higher level data, not just this low level 2 data, probably use some level 3 data. And here we go. Got 6 images that probably got processed into that outreach image. And you can look at the actual science data yourself. You can download them. You can have a quick preview of the actual image. Just click like that and we see something very familiar. And we can download them all and so on. Maybe you want to download several of them like that. We can download all the metadata and so on as well. So this is basically a core use case of ESASky, but it's not really focused on any specific missions like James Webb. We are really project agnostic. So this is a tool for all kinds of astronomy missions. So it's not just images. You can zoom out. Let's say we're interested in some other part of the sky. We can just go to that part of the sky and see what kind of data is available. So let's zoom in here, for example. We'll see that these numbers will update as soon as we stop zooming. And we'll see that there are 600 images taken of this part of the sky, a lot of catalog sources and some spectra. So if we zoom in a bit more, we can see that there are some spectral data. If you want to do some spectral research, right? You see some familiar missions here, like LAMOST, for example, from Chinese. Got it here. We can get all the actual data from LAMOST right in the browser and can download it, can go to the Chinese archive directly like that I showed you before. Of course, this will take a few seconds since we're going all the way to China and back to get the information. But here you go, the Chinese archive, and this will load soon. There we go, the spectral data from LAMOST. And we'll see the footprints over here. Here are the actual sources. All right, so if let's say we want to do some more research, we'll zoom in and for some reason we want to do research in this area. You can see what's available in this area. For example, from Gaia, from TUMAS, all the catalog sources from TUMAS are available here. Maybe we want to do a more specific cone search around this area. We can do it like that, and we have the numbers update for that specific cone search. And if we can also do a little polygon here, some arbitrary polygon. Say we're very, very interested in this particular part of the sky. We can easily access what is available in this little polygon that I just created. So for example, here we got the Gaia data loading directly from the Gaia archive, and we'll see the little pointy things here indicating their proper motions in the sky. And we got all the metadata from Gaia. So plenty of columns. We're actually only showing like 40 of them here, but of course Gaia is famous for having many columns. So if we right click, we can actually put up, display all the columns that we are interested in. Let's add a few more. Maybe we're not interested in these columns. Can disable them, basically easily customizable. And of course you can download them in a CSV, download the things that you're interested in, maybe just those, or download a VO table, which I'll get back to what that is in case you're not familiar. And we can also send the data to other astronomical applications like TopCat, like Aladdin desktop, for example, in case you want to continue your research at those locations with those applications. All right, so the thing that I want to talk about regarding these things is the reason that we can do these things, like sending the data to other applications or downloading a VO table is because of these things called VO. And it's basically the Virtual Observatory. And it's a way that allows us to display all the astronomical data easily. And it's basically a way that has standardized the way that data is published. It's through these big organizations called the IVOA, or the International Virtual Observatory Alliance. And they have been working on standardizing the way that data has been published for probably 20 years or more at this point. So it's pretty well developed. And all the big astronomical institutions are part of that organization. So a lot of standardization work has gone into this kind of standardizing the way that different astronomical applications talk to each other, the way that data is being published, and that basically is the whole reason that we can build a tool like ESASky, which is very, very project agnostic. Basically, we just use whatever these people provide us, all the work that has been done, we just use all of that, and that's all thanks to the Virtual Observatory standards. And that's why this video table is a very, very common standard that you may want to download and put into other applications as well. It's a very, very useful standard when you work in astronomy. Anyway, the other things that you can have a look at is this thing called the External Data Center tab. And this is where we have not even touched the data at all for all these 3 buttons, or we have dozens and dozens of missions with science-ready data that you can access, and we have them directly in our databases, so we can do some really amazing things. But for this button, we are only pointing to these big institutions, so we can't do all of the things that ESASky can do, but at the same time, this allows us to really, really expand the number of missions that are available through ESASky. So for example, here, I'm querying the European Southern Observatory, I'm querying MAST, I'm querying CADC, for example, and asking them, hey, give me all the data that is available in this part of the sky. And we can easily just add it like this, hopefully. See if we get some data from tests. And there we go, got some data from tests. Let's see, I think they have really, really large footprints. So here they are. All right. And of course, thing I didn't show you before is that we got so many missions here that maybe you're just interested in some part of the wavelength spectrum, then you can easily filter out the part of the wavelength spectrum that you're interested in, and you get a little tree map that is way easier to read. All right, but let's say we want to continue our research on these two little galaxies around here. Then it's a reasonable thing to ask yourself what kind of thing have been published in this area before. So we got a little tool for that as well here in ESASky. So we can see what kind of thing people have published regarding these sources before. So for example, here we go, we got 2 sources for this particular source in the sky. We got 10 publications for this source in the sky. We got 14 for this, and we can actually look at these specific publications as well. And we've got all the 14 publications, and we can actually go to that specific publication in NASA ADS and see the actual paper that was published. Maybe very interesting to you in case you want to do some additional research in this regarding this galaxy, for example. And we can also see what other sources they talked about in this paper. So just clicking that button will ask Simbad what kind of other sources they talked about in this paper. We'll get a long list of things like that. And this feature is once again heavily dependent on work that has been done by other people, not just people in ESASky, because we're a very, very small team in ESASky. But in this case, has been a lot of work put into the tool of NASA ADS, for example, and of course CDS as well have done a lot of work to enable us to create powerful features like this. ESASky is really built on all these virtual observatory standards, so hard work by lots of people, not directly working on ESASky, and we also have users of services developed by other people and institutions. In particular, we are heavily dependent on services from CDS, for example, from NASA ADS, from the IVOA. So we are, for example, using Aladdin, which I think many of you are aware of or using. That's developed by CDS. We're heavy users of many of these amazing services from these people. And if you're interested in some specific person, let's say we want to, for some reason, we found this paper very, very interesting. We can actually just see what other papers this person has published. So I can just search for this particular author. And we get all the papers that this person has published before. We can dig into that in case we are very interested in those kind of things. And we'll also see what kind of sources this person has talked about in his paper in case that's interesting. I think it's a nice and quirky little feature in case you're interested. And as you can see, we have a lot of features in ESASky. And that's basically because this guy has been in development for a long time. It was initially started in 2014. And then the first version was released in 2016. And that's also when I joined the team. And the goal has always been to facilitate data discovery and data access. And we have also focused on keeping the tool project agnostic and multi-wavelength, so we can really access data from any kind of mission and use the same kind of tools for analyzing the data. All right, so the last thing I want to show you here on this web view is basically the background imagery. It's a thing called HIPS, and that's basically the thing that allows us to zoom in and zoom out on the background imagery. And this little button here is the very famous DSS2 color background imagery. But maybe you're not too interested in the optical wavelength. You may want to change it up to some other. We got plenty of background imagery. We got integral data. We got some data from Planck as well. In case you're interested in those kind of wavelength spectrum, and we can of course do some mix in between different background images as well. And again, we got an amazing feature thanks to the standardization that has been going on through the IVOA and all the hard work done by different people at CDS again, for example, that allows us to basically browse every single background image that has ever been created and published. And as you can see by this little drop down here, this little scroll bar here, there are a huge number of background imagery available. And we can just plot them directly into ESASky if we want to. Let's say we are interested in Pound stars, for example. Can you just pop that into ESASky, and there we go. We got a specific background that we want, or maybe you're interested in Gaia, for example. We can add the Gaia density map there. Could be very useful if you are not very interested in the optical background imagery. And of course, you can slide between these different backgrounds as well. Anyway, other things that you can have a look at yourself, I encourage you to have a look at yourself, is that, for example, we've got a feature for gravitational waves and neutrino events, in case you're into that kind of astronomy. I encourage you to have a look at this yourself. We got a way to plan your observation time for the James Webb Space Telescope. So in case you want to get some time on that, I encourage you to try that out. And of course, if you're interested in doing some solar system research, you can search for your solar system object of interest, and you'll see what kind of data we have for that specific solar system object. We basically have an algorithm that figures out all the time that this object has been in the field of view of an observation. So both targeted and serendipitous observations of that particular solar system object. Could be very useful to some of you. But ESASky is more than just a web page. So we also have other ways of utilizing the power of ESASky. Of course, here's a long list of credits. I'm sure it's incomplete, but it just gives you an idea of how many people have been involved with ESASky in different ways. Even though the core team is very, very small, there are people from around the world that have helped out somehow to create this great tool. But the thing I really want to talk about was the other things that we have of accessing ESASky, not just the web page. So you can also use a thing called AstroQuery. I'm sure some of you are familiar with this tool. We got an ESASky module there in AstroQuery. Basically allows you to access all the data that we have in ESASky through your Python environment. And that's very useful because a lot of astronomers use Python, and there are so many amazing tools written in Python. So maybe you want to do some data processing on the actual data products, then Python is a really great way of doing it. And in particular, if you want to download a lot of data, I encourage you to use this AstroQuery module to do that. So, for example, you can install it easily. Just do a pip install AstroQuery like that, and you have it on your machine. And you can easily just import it and ask ESASky for, give me everything, every image taken of M51, for example, in this case. And you have all that data in your little Python variable like that. And you can do the same thing, just specifying a region, give me all the images in this region. And of course, you can also download the actual images. So you get the real FITS files directly in your Python environment and on your machine. And this is just an example of looking at the header of one HDU from XML, in this case, when I've downloaded them. So I think this is very familiar to any of you that have used Python in your astronomy work before. It's just a very long header file there. And of course, we've got other features in AstroQuery as well. So you can use the solar system object feature that I talked about before. Give me everything on this particular solar system object. And we got to, of course, download spectra, download the catalog data, do those things as well. All right, and the last thing that I wanted to show you was also the thing kind of in betweener between AstroQuery and the web module. So we got this thing called PyESASky. You can easily install it like that. I've got some documentation there as well. And it's basically a mix between the AstroQuery way of working and the web page itself. So I got a notebook here as well. Of course, these notebooks are public, so you can just try it out yourselves when you have time, if you're interested. But basically, this will allow us to create a little window here of the actual ESASky webpage, and we can talk to it directly through our Python code. So you can do a lot of things in the Python side, and you can send it to the webpage, and you can take data from the webpage and send it to Python. So there's really an entire set of Python commands that allows you to command the actual webpage. For example, going to some specific part of the sky, setting the background imagery, asking what's available in this part of the sky. Maybe you want to plot some data directly into ESASky. You can use your own data to plot into ESASky. Or maybe you want to just ask for the XMM data into Python, and you do some processing there, and then you push back the result for visualization into ESASky, and you can do things like that. So many powerful features, and here you can see that we're using a lot of the Python libraries that allows us to create images like this. So in case you haven't used Python in your astronomy work before, I encourage you to have a look. Because there are so many useful tools out there. Anyway, the kind of last part of this talk, I would just like to show you what we have in store. So we got, this is the integration version of ESASky, so it's not yet publicly available, but we do have some exciting feature coming in a month or so it should be available to you soon. So basically here we get to have the external data center button, which previously just asked five data centers what kind of data they have in this part of the sky. But now we have expanded this to include basically all astronomical data in the world. So basically here we can ask, again, thanks to the work of the IVOA, we can see what kind of all the astronomical data we can put it into ESASky. So I know that a lot of people have asked for data from VCR, for example. We can open that up here. So if we open VCR, we got tens of thousands of tables that are easily plottable and downloadable, and you can use all the standard tools of ESASky on any of these tables. So let's say we're interested in some dark energy stuff. Now we can have a look at this specific table. We can do our own query. Maybe you want to write whatever you want here, and to get the data into ESASky. You can do different ways. So for example, here I can select the first 1,000 rows of this table, and it should ask this VCR for the data. Maybe we want to ask for all data from this table in the field of view, and we can do it like that. And all data from this table in the field of view should load. So let's wait for it to load. There we go. Got almost 4,000, almost 5,000 rows in just this field of view. So it's basically allows us to get data from anywhere nowadays, using this feature that we will release in a month or so. And you can also get data from other things, not just VCR. So for example, if you want to get some Gavo data, we can go to the Gavo data center and ask for any data from them. See how long they take to respond to us. There we go. And we can search for something. And here they have some specific type of table that allows us to actually add this information to our little tree map here. So now we're asking Gavo to tell us everything that is in the field of view. Please give me everything that is in the field of view, and they have many, many tables. So here we go. In this field of view, 3 of the tables actually have data in this field of view, and as we zoom around here, this number will update. So it's a very, very powerful tool that is coming to ESASky very soon. And other plans that we have for ESASky over the next year or so, I think we got many, many plans, of course, but one of the biggest one will be to upgrade this entire viewer that we have of the sky. So as you know, this is basically Aladdin Light version 2 that we have. It's a very great tool that has been around for over a decade, I think. So at this point, it's using quite old technologies. And that's kind of a limitation sometimes when we want to display, for example, want to be able to display the actual FITS file here in the great part of the sky and allow you to play around with the dynamic range of the FITS files and so on. And for that, we need a tool that is built on WebGL. So we will be upgrading this viewer in the next year. And basically, we will look into any of these viewers that have WebGL support. For example, WAS, Worldwide Telescope, has had WebGL support for a long, long time. And I actually develop the FITS visualization for that tool in WebGL last year, I think. So we'll be looking into things like that. Of course, I think Aladdin Light 3 is releasing any day now as well. And the people at CDS are very talented as well. So we will have a look at maybe just upgrading to Aladdin Light version 3, which will allow us to display all these really, really amazing things. And that's basically what we have, the big things that we have planned for the next year. And the last thing I want to say is basically this tool is developed for astronomers like yourselves. And it's basically focusing on easy access to the world's astronomy data. So you can focus on pushing the bounds of astronomical knowledge. And I encourage you to try it out. In case you have any problems, we have a feedback button. In case you want to ask for specific features, I encourage you to write to us with our user echo here. If you just enter the feedback there. And that's all I wanted to say. So thank you.